Our next topic is going to be polar coordinates. Now, polar coordinates are juxtaposed next to our standard Cartesian coordinates, which are x and y, which is how we think of the coordinate plane. Usually so far in algebra, we've got the x-axis is the horizontal axis, the y-axis the vertical axis, and then we determine where we are in space by knowing how far left and right to go, and then how far up or down to go. And we just find those x and y points. And that tells us where we are on the coordinate plane. In polar coordinates, instead of using x and y as our two coordinates, we're going to use r and theta. So r for the radius and theta for the angle. So when we're in polar coordinates, instead of describing how far left or right to go and then how far up or down to go, we'll first decide how far away from the origin we want to be. That's the r value or the radius value. And then what angle we should take in order to find that point. And theta, being that angle, works the same as it does on the unit circle. We start in standard position, and that's 0 radians, and then we measure counterclockwise, and if we go all the way around the circle, we get 2 pi. So we, in fact, have already been working with polar coordinates this entire semester because the unit circle is in polar coordinates. It just happens to be a fixed r value of 1, because the radius of the unit circle is 1. And we just look at various angles as we go around that unit circle. So in problem 1, we're going to be using these 5 points, A, B, C, D, and E, and locating them on the coordinate plane, which this diagram that's here to the left is just the coordinate plane like we're used to. You can see the vertical and horizontal axes are still there. But I've added in a few extra pieces in order to help us find spots within the coordinate plane. So I've put a bunch of circles moving outward from the origin so that each circle can represent a length of 1. So sort of instead of putting tick marks on axes like we would in Cartesian or rectangular coordinates, I'm going to put out these circles instead. And then I've marked several angles along this circle as well. So that each angle is going to count by pi over 12, since that's the least common denominator that will pick up each of the angles that are on the unit circle. So pi over 6, pi over 3, pi over 4, all that kind of fun stuff. So on this coordinate graph for the polar coordinates, each tick mark for those angles will be a change of pi over 12. So let's zoom in, and it looks like our smallest circle right here, that'll be at a distance of 1 away from the origin, and then there are 8 of these circles. So the large one all the way on the outside is an R value of 8, while the one all the way in the middle is an R value of 1. So if I want to locate my first point, which is A, it is at an angle of pi and an R value of 5. So we'll come out to an angle of pi, which means this line right here. If I use my ruler to draw a straight line there. And then I want to find point A, which means going out 5 circles from the center. So 1, 2, 3, 4, 5. Should put our point right there, and I'll label it point A. Underline that in blue. Next, we'll locate point B, which is at an angle of 5 pi over 6 and an R value of 8. So 5 pi over 6 would be 30 degrees up from the left axis. So we're looking along this line right there. And I can draw it to be a little bit straighter than that. So we are at an R value of 8, so a distance of 8 away from the origin, which is going to put us out here on that furthest away circle. So that's point B, which I'll underline in red. All right, finding point C, which is at an angle of negative pi over 3. So negative pi over 3 should be at 60-degree angle down here into the fourth quadrant. Highlight that green line right here. And at negative pi over 3, we're going to go out a distance of 4 from the origin. So count out 4 circles. 1, 2, 3, 4. Puts us right here. Then for D, I want an angle of pi over 6, which will be that 30-degree angle up into the first quadrant. So if I draw this purple line, which is theta equals pi over 6, I have an R value of negative 2. So if that were a positive 2 as our R value, we'd end up at this open circle drawn in right there at that distance of 2 away from the origin along the line pi over 6. But we actually have an R value of negative 2, meaning that we should actually take this and go backwards along the line pi over 6. So instead of ending up at a point in the first quadrant, we end up at a point in the third quadrant, which is right here. And this is point D, not C. Got off by 1. So I'll highlight that in purple. So a negative R value simply means I go backwards along my angle instead of forwards. So if you noticed on a lot of these lines, I drew them so that they would go beyond whatever quadrant the angle itself was in. That's so that I could trace it backwards if I needed to. And finally, we'll get point E, which has an R value of negative 3 and an angle of negative pi over 4. So negative pi over 4 is going to be that 45-degree angle that's into the fourth quadrant. Just line up our straight edge right here. And we're looking along this yellow line, which again would be the line theta is equal to negative pi over 4. And while if we had a value of positive 3 for our radius, we should end up at the third circle at the open point that I drew in, a distance of 3 away. But again, that would be a positive 3 value traveling in the direction of negative pi over 4. But we actually have an R value of negative 3, which means we need to go backwards in the direction of negative pi over 4, which really means we're going forward in the direction of 3 pi over 4. 1, 2, 3, we should be at this point up here, E, labeled there. All right, now that we've plotted each of those points, the next step that I want to do is to convert each of them from the polar coordinates that they're already in, again, that being R and theta, and change them back to rectangular coordinates, which means going back to X and Y. So highlighting a couple of equations from the polar concepts box here at the top, I know that x is going to be r times cosine theta, and y will be r times sine theta, which we can get just by creating a triangle out of whatever point we have. So create the reference triangle that we've been using so far this semester. And if r is that hypotenuse, that means that x is the adjacent side and y is the opposite side, because we'll always connect to the x-axis in those reference triangles. So x will be r cosine theta and y will be r sine theta. R cosine theta and y equals r sine theta. And we'll go through each of these points and find their x and y values. So for a, r cosine theta, if I'm playing in 5 and pi, I'll get 5 times -1, which will be 5, while r sine theta will be 5 times 0, which is 0, giving us the point -5, 0. On to point B, the cosine of 5 pi over 6 is going to be negative square root of 3 over 2. So multiply that by 8, and I'll get -4 square root of 3. Sine of 5 pi over 6 is positive 1/2, so 8 times 1/2 will be 4, giving us the point -4 root 3, 4. On to point C. If we're going into that fourth quadrant, the cosine of negative pi over 3 is 1/2. So 4 times 1/2 is 2. While for the sine value, I get 4 times negative root 3 over 2. It's -2 square root of 3. So 2, -2 root 3. On to D. We're going to end up in the third quadrant, so I should know that both x and y are going to come out negative. So -2 times the cosine of pi over 6 is going to be just negative square root of 3. And -2 times the sine of pi over 6 is going to just come out to 1. Since 2 times 1/2, -2 times 1/2. Right, we said this is the third quadrant, so both of those should come out to be negative. So negative root 3, -1 is our point. And finally, point E, we're at -3 times the cosine of negative pi over 4 is going to be -3 root 2 over 2, while -3 times the sine of negative pi over 4 is going to come out to +3 root 2 over 2. Let's try that again. -3 root 2 over 2, +3 root 2 over 2. All right, on to problem 2, where we're going to, as we saw up in the last couple of examples in problem 1, we can work with both negative angles and negative r values. And in fact, anytime we use a negative angle, I could always find just a different positive angle that could measure into that same direction. And we're already kind of used to doing that from when we were looking at the negative fourth quadrant, where we did all of our sine, cosine, and tangent inverse problems. Specifically sine inverse and tangent inverse, since those are the ones in the negative fourth quadrant. So in problem 2, I want to describe these same points, but with once with a negative angle, and then a second time with a negative r value. So I've already labeled in all of the r values because that number for r can't change no matter what angle we use. And if we're going to use a negative r value instead of a positive one, it should still be that same number, just with a negative on it. So for point A, where we had r equal to 5 and theta equal to pi, my only options for r are positive 5 or negative 5. No other r value is going to work. But there are an infinite number of angles that I could use to describe that point. Usually we like to stick to just using angles that are on the unit circle, so between 0 and 2 pi, but occasionally we'll want to use some additional angles, like perhaps a negative angle. So in part A, I wanted to find this same point, but with a negative angle instead of a positive one. So an angle of pi measures directly to the left, but I also know that an angle of negative pi would measure directly to the left, since if I just subtract 2 pi from pi, I'll get a coterminal angle that points directly to the left. Now for part B, I want to describe the point 5 theta, which again is that point all the way to the left at a distance of 5 away from the origin. But now I want to describe it using a negative angle, which means I'm looking for the direction that is opposite of pi, rather than direction directly in pi. And looking back up at the circle here at the top, the direction exactly opposite pi would be 0 radians, since both pi radians and 0 radians describe the same line of x equals 0. So I could also have the point negative 5, 0, which would get me to that same point A at 5 pi. Additionally, just for fun, we could also use an angle of 2 pi and say that that is exactly opposite an angle of pi as well. But we'll just do that for part A, or for point A. All right, on to point B. So finding a negative angle for 5 pi over 6, this really just means finding a negative coterminal angle. So coterminal to 5 pi over 6 would be negative 7 pi over 6. Again, I can just subtract 2 pi to get that number. The more interesting one is, well, what if I wanted to use a negative r value? So what angle is going to end up opposite of 5 pi over 6? And that would be either 11 pi over 6 or negative pi over 6 if you wanted to use the negative fourth quadrant values. But so since 11 pi over 6 is exactly opposite 5 pi over 6, if I started in a direction that was 11 pi over 6 and went backwards, I could end up at the point 8, 5 pi over 6, just like where we started. Right. For point C, I already have a negative angle theta in negative pi over 3. So I'm going to change it slightly and just find a point that has a positive angle. So keeping that same positive r value of 4, we'll find a positive value for theta. So negative pi over 3 is in the same direction as 5 pi over 3, meaning that the point r equals 4, theta equals 5 pi over 3 is the same as the point where r equals 4 and theta equals negative pi over 3. And then for part B, finding a negative r value, which means I need the angle that's in the opposite direction of 5 pi over 3, and that should be 2 pi over 3 up in the second quadrant, since the second quadrant would be in the opposite direction of the fourth quadrant. For point D, so this time we already had a negative r value, so we'll find a couple of points with positive r values instead. So if I already have the point that's at negative 2 and pi over 6, that would be the same as going, So that means I'm going backwards in the direction of pi over 6. And going backwards in the direction of pi over 6 is the same as going forwards in the direction of 7 pi over 6. And from there, we'll find a negative coterminal angle to 7 pi over 6. And that should be negative 5 pi over 6. So technically, I've sort of kind of switched the parts A and B on those 2 points. But A and B already kind of went out the window since I was starting with a negative value anyway. Moral of the story is that all 3 of those points all go to the same point in space. So all 3 of those coordinate pairs go to the same point in space. And finally, point E, I start with a negative r value and a negative value for theta. So we'll just like to make both of those positive. So I was going backwards in the direction of negative pi over 4, which means I would want to go forward in the direction of 3 pi over 4. So again, those 2 coordinate points measure the same point in space.